Hey guys, today we're going to be looking at measures of position. Up to this point we looked at measures of center, also known as measures of central tendency, things such as mean, median, mode, and then we moved on to measures of variation. So we looked at things such as range and standard deviation. So at this point we've seen how numbers can be used to sum up a bigger group, such as using the mean to say the average is this, or the mean to say what happens in the middle is this value. We've seen range and standard deviation as being a measure of variation to tell us how spread out the numbers are. But now we also have measures of position to show us how the data is actually distributed across that range of values. So by having the means of measures of central tendency and the measures of variation, as well as the measures of position, it gives us a very good idea of what's actually going on with our numbers. So the first piece of information we actually have with measures of position is dealing with what are called Frac Tiles. And Frac Tiles are simply going to be numbers that partition or divide an ordered set of data into equal parts. Now, there's many types of different Frac Tiles, which we'll be getting into here at the end. But the most important one that we actually have in statistics is what are known as quartiles. Quartiles actually divide the data into 4 equal parts, which if you think about it, quarter and 4, they go together because there's 4 quarters in a dollar, so therefore 4 equal parts. Now, we actually have 3 numbers that are actually making up those quartiles. So if we have quartile 1, quartile 2, which is also known as the median, and quartile 3. Now, as it goes into a big grand scheme of everything, if we have our range of values, alright, so here's all of my numbers on that number line. Right in the middle, I'm going to have quartile 2, which as you can see, it actually splits all the numbers in half. So I have 50% on the left, 50% on the right. And then I have quartile 1, and I have quartile 3 also added in there, which actually breaks the numbers up into 4 pieces, because we had 3 division marks. As you can see, there's how the numbers are actually distributed across the whole grand scheme of the data. Now, these quartiles are actually pretty simple to find. So we're actually be going into our first example, because it's actually a little bit easier to show how they're actually found than actually trying to explain it. We want to find the quartiles of the following data set. And I have a set of numbers here of 27, 6, 31, 14, 17, 19, 35, 48, 51, 128, 55, 77, 19, 22, and 36. Now, basically what we're doing whenever we want to find quartiles, we want to find different medians. So in order to find the median, I have to put the numbers in order. So my first number is going to be 6, so I'm starting with the lowest number. And from here, we're going to start looking at the next ones, which look like to be 14, 17, 19. And we actually have 2 19s. From there, it looks like we're going to go to 22 and 27, 31, 35, and 36. Followed by a 48 and a 51, a 55, a 77, and a 128. So we have all the numbers put in order, and basically from here I'm just going to go through and start finding the median, which as you guys know, to find the median I'm simply going to locate the number in the middle. So instead of crossing them out for you guys, I'm just going to underline them to make my life a little bit easier, since we'll have to reuse the numbers. And we're finding that the median is going to be 31. But as we also mentioned, the median is also known as quartile 2. So therefore, I now know quartile 2. But I need to also know quartiles 1 and quartiles 3. So I'm going to use a different color here, use light blue. And what I'm going to do at this point is I'm just going to go through and find the median of the other 2 lower pieces. So, for example, 31 here, this is my quartile 2. I'm going to find the median of all the numbers to the left, followed by the median of all the numbers to the right. So on the left, I have the numbers 6, 14, 17, 19, 19, 22, 27. Finding the median here gives me a value of 19. This is my value of quartile 1. And on the right, I have 35, 36, 48, 51, 55, 77, and 128. If I find the median of these numbers, I will find 51 is the median there, which is actually corresponding to quartile 3. So basically, I'm going to go through and take all my numbers, put them in order. I'm going to find the median. That median is going to be known as quartile 2. And I take all the numbers to the left of that median, which is going to be quartile 1. And then I find the median to all the numbers to the right, that's going to be quartile 3. So therefore, I very easily can find the quartiles. And you might say, Mr. Smith, that's great. What's that tell me? Well, I know that 25% of all the numbers is to the left of that quartile 1. I can say 25% of all the numbers are between the median of quartile 2 and quartile 3. I can go through. But it also leads us into the next piece, which is allowing me to look for outliers. All right, because there's actually a very neat interquartile range test for outliers. The interquartile range is actually a measure of variation that gives the range of the middle 50% of the data. Right? So we go through and find the interquartile range simply by taking the value of quartile 3 and subtract the value of quartile 1. So usually it's a very easy calculation. This formula is not on your formula sheet. So I recommend putting it on there in the bottom of the first page. And also putting the interquartile range test, which I'm actually circling right here. This should also go on your formula sheet because it's also not there. These two things are very important. The book actually touches on them, but they don't really go into much detail, which for some reason I do not know. If I was writing my own textbook, it would be a whole little section of itself. But because it's not on your formula sheet, please make sure that these two things that I've circled on the screen get there. Once you have the interquartile range calculated, you can simply go through and say, well, any values that are less than the value for quartile 1 minus 1.5 times the interquartile range, or outliers, and any values that are larger than quartile 3 plus 1.5 times the interquartile range are going to be outliers. So if we go back to that last set of information we had the same set of numbers, which means I've already done all the footwork. I already know that quartile 1 is going to be 19, quartile 2 is going to be 31, and quartile 3 is going to be 51. So I already found those values. So in this case, I want to locate and determine, do I actually have any outliers here? So we know first that any values less than quartile 1 minus 1.5 times the interquartile range are going to be outliers. So I'm going to go through. I'm going to plug in my information. I know quartile 1 is 19. I have 1.5 times my interquartile range, but I don't have that calculated yet. So if I want to find my interquartile range, we know that it's simply going to be quartile 3 minus quartile 1. Quartile 3 is 51, quartile 1 is 19. Therefore, my interquartile range is going to be 32. So from here, I know my interquartile range now is 32. Following the order of operations, 1.5 times 32 is going to be 48. So we have 19 minus 48, which is essentially going to be negative 29. We do not have any outliers on the negative side because all of our numbers are from 0 and up, and our smallest number is 6. So that range test, the first piece, didn't actually come up with any outliers. But we also have the second piece of the outlier test, which are dealing with values that are greater than quartile 3 plus 1.5 times the interquartile range. So we plug these in this time. Quartile 3 is 51. I have 1.5 times my interquartile range of 32, which we found over here on the side. 1.5 times 32 is still 48. So I have 51 plus 48, which is 99. And this time you'll notice, hey, we do have an outlier of 128. So therefore I know that because 128 is larger than 99, 128 is an outlier. So here this is actually a very, very interesting piece of information, very good to identifying outliers, which are very common in statistical studies. So it's good to know how to find them and being able to actually justify that, hey, this is an outlier. This normally does not occur. So you can properly adjust your data and actually back your data up properly. Now, from here, we have one of the last things dealing with quartiles, which is essentially the 5-number summary, which you've probably heard about in previous math classes because it's always talked about when you get into box and whisker plots. And I'm pretty sure that right now when I'm saying box and whisker plots, you are probably sighing and starting to moan and groan because you hate box and whisker plots. It's just so terrible. But they're not that bad. Because as I went through and showed you guys, you had to find the first quartile, the second quartile, and the third quartile. Well, that's 60% of the 5-number summary, and the other 40% are really easy. It's essentially just going to be the minimum entry and the maximum entry. So if you can identify the smallest number and the largest number, find the median, and then find medians of the other 250% of the data, you have the 5-number summary. Now, the 5-number summary is really not that big of a deal. It's like I said, it's pretty simple to find. I've already gone over how to find quartile 1, quartile 2, quartile 3. You should really not need any help finding the minimum and the maximum data entries because they're pretty simple to find if you have the numbers in order. But what this is actually used for is to create box and whisker plots, which here I have a list of 5 steps to actually creating a box and whisker plot, and I'm even going to draw a picture to help you guys out with this, because it's even better to actually visualize what's going on with the box and whisker plot, not just, hey, here's the steps. Now, my first step is to go through and define the 5-number summary. So I need to put the numbers in order, find the median, and then that splits the data up into 2 other pieces. Find the medians of both of those pieces, so I have quartiles 1, 2, and 3, and then find the minimum and maximum data values. Once I have those 5 things taken care of, I'm going to actually move to step 2, which is to construct a horizontal scale that spans the range of the data. So I'm basically going to have a number line that's horizontal, which I'm going to be using to actually make my box and whisker plot plotted above that. 3 is to plot the 5 numbers above the horizontal scale. So if I have numbers, I'm just going to use here, I'm going to use my minimum entry first. I'll say maybe here's quartile 1, here's quartile 2, here's quartile 3, and then over here I have my maximum value. All right, so I have all that. I plot the numbers there. I'm going to actually use the actual numbers for whatever we have. 4, draw a box above the horizontal scale from the first quartile to the third quartile and draw a vertical line in the box at the median. So I'm going to have a box that ranges from quartile 1 to quartile 3. So there's a box, which is the box part of the box and whisker plot. From there, I'm also going to put a vertical line at quartile 2, which just basically breaks that box up into 2 25% pieces of all the data. And my last step is to do the whiskers. So I'm going to draw whiskers from the box to the minimum and maximum entries. So here's the box. I'm going to draw it out to the maximum entry. I'm going to draw one to the left from the box to the minimum entry. And that's all I'm doing for my box and whisker plot. Now, we have an example of this, which is the same example from before, where we went through and we found that quartile 1 was 19, quartile 2 was 31, quartile 3 was 51, which now I have 3 out of the 5 pieces of my 5-number summary. But from here, I also have one other piece that I need to do. I need to actually go in and add my minimum entry and my maximum entry, so I have my 5-number summary. If you look back at the first example that we did, we had the numbers already in order. You would have actually found that 6 was my minimum value and 128 was my maximum value. So I have to go through and make a box and whisker plot representing this 5-number summary that I have boxed in. Now, outside of this, it's not so bad. That's my first step. It's already done. It's already taken care of. My second step is go through and create this number line that ranges this entire span of the numbers. So there's my number line. Even though it's a little crooked, it'll still work out. Keep in mind, I don't judge you guys and grade you guys on your drawings. As long as they can look close, I'm happy. Now, my smallest number is going to be 6. So it's going to start there at 6. 128 is going to be out here. So we're going to start working on step 3 with actually labeling the number line. So it starts at 6. I have over here 128 way out here on the right. That's my maximum value. I'm going to put the quartiles 1, 2, and 3 sort of somewhere where they correspond to what's going on. So if 6 is here, I'm going to move somewhere out here for about 19. Move over a little bit more for 31. Somewhere over here for 51. And then I still have 128 way out here. So I put the numbers somewhat close to where they should be. Once again, I'm not grading you for your exact drawings and everything. Just try to put them as close as they can get. And now I'm just going to draw a box over ranging from quartile 1 to quartile 3. So essentially it's going to be right in here. There's my box. I'm going to draw a vertical line at quartile 2. So I have it right there. And then I make my whiskers going from the box out to quartile to the maximum value and to the left to my minimum value. And there's my box and whisker plot. What these actually mean, what they actually tell us, we'll get into more detail next time. But for now, I just want you guys to know how to draw them so you guys have an idea of how to make them and breaking the 50 and 25% of the data up. And we have one last piece, which is actually, like I mentioned, the other types of fractiles that are out there, which are quartiles we already went over. They divide the data into 4 equal parts, and they're represented with the letter Q because, hey, it's a quartile. Quartile goes with Q. We also have what are called deciles. These are not used often. As I noted there, they're rare. They're very nice and neat because they break it up into 10 percentage groups. But other than that, you don't really see them too much. The book likes to use them because they like to trick you up. But once again, they're represented by the letter D because, hey, deciles works and starts with D. The last one, which is actually very important as well, are percentiles. These are the ones we're not really going over. Basically, they're denoted with the letter P, and they break it up into 100 equal parts, just like a percent. So these are actually used a lot when you guys take SATs, or if you look at growth models, you might say, oh, this child is in the 37th percentile for weight, or you scored in the 87th percentile in the SATs. It essentially means that you did better than that percentage of students. So if you're in the 87th, we'll just do it this way since I can't write today, 87th percentile, it means that you did better than 87% of everyone else that took it. So if you're in the 100th percentile on the SATs, pretty much you're the best. If you're in the 2nd percentile, you might want to rethink what you're doing with the SATs because something's not working. All right? So other than that, that's what I have for the first piece of section 2.5, dealing with percentiles, box and whisker plots, and fractiles. We will be going over this in class next time, so feel free to make sure all the notes are taken, go through and rewatch the video as needed, and be prepared for class so we can go into the material. Have a wonderful rest of the day.